Welcome to this video on System Configuration and Performance Evaluation, part of the course CSE 06-13307, focusing on system analysis and design. We will cover an overview of a complex system architecture. What exactly is a system? Derived from the Greek word systema, it is an orderly grouping of interdependent components linked together to achieve a specific objective. Components are interdependent, meaning they cannot function alone. For example, a food delivery system relies on the user app, server, restaurant app, and driver to achieve its goal. Every successful system relies on three basic implications. First, a predetermined goal defines its purpose. Second, interrelationships ensure components are connected. Finally, system priority means the objective of the whole system overrides the objectives of its individual subsystems, as seen in the Google search architecture. Key characteristics of a system include organization, which provides order and hierarchy. Interaction dictates how components communicate. Interdependence highlights their mutual reliance. Integration ensures seamless fitting together, and central objectives guide all activities. Remember, without integration, you only have a collection of parts. To analyze any system, we look for 6 standard elements: input and output, the processor that transforms the input, the control that dictates actions, feedback for correction, the external environment, and the boundaries that define the system's scope. Consider the real-world example of Amazon's e-commerce architecture. Inputs include user clicks and inventory data. The processor runs recommendation algorithms. Output is the shipping label and confirmation. Control involves fraud detection, and feedback comes from user ratings and return rates. Delving into detail, inputs are the raw materials, like data in software. Output is the processed result that must meet expectations. The processor is the black box that transforms the state of the input, and it must be dynamic to adapt to changing output requirements. The control element acts as the management layer, setting rules and policies for the processor. Feedback is crucial for dynamic systems, comparing actual versus expected output. Positive feedback reinforces behavior, while negative feedback prompts corrective action, forming a closed-loop system. The environment is the supersystem in which the system exists. Changes in the environment, like new laws, force the system to adapt. Boundaries define the scope limit, and the interface is the critical connection point where the system interacts with the outside world. System design is the process of defining the architecture, modules, and interfaces to satisfy specified requirements. It acts as the critical bridge between system analysis and code implementation, focusing heavily on scalability and maintainability, as demonstrated by the architecture of messaging apps like WhatsApp. Design goals ensure the quality of the final product. These include practicality for the target audience, accuracy in meeting specifications, completeness in covering all requirements, and efficiency for optimal resource usage and low latency. Other crucial design goals include reliability for a failure-free environment, optimization for faster and cheaper operation, and scalability, which is the system's ability to grow without major code changes. Failing to achieve scalability, as seen with companies like Nokia, can be detrimental. The System Development Lifecycle, or SDLC, is the blueprint for the entire project life. The standard cycle includes planning, analysis, design, implementation, deployment, and ongoing maintenance. The first stages of the SDLC begin with recognition, which leads to a statement of scope. Feasibility determines if the problem is worth solving and leads to a cost-benefit analysis. Analysis determines what the system must do, resulting in requirement gathering. Stage 4, design, determines how the system will solve the problem and produces detailed design specifications. Implementation involves coding and building, resulting in working software and user manuals. Finally, maintenance ensures the system runs well, generating patches and updates. Thank you for watching this video on system design and analysis.